Every year, the United States produces billions of bricks, enough to build millions of homes, create entire new neighborhoods, and support the towering skylines of its great cities. From the vibrant red walls of Texas to the historic facades of Boston, the mark of brick runs deep through every layer of modern architecture. Behind these seemingly ordinary blocks lies an extraordinary transformation, beginning with raw brown clay extracted from the earth, ground fine under the power of steel, compressed into molds, then forged in massive kilns at over 1,000 degrees. By the time they leave the fire, they are no longer mere earth, but resilient building units carrying the story of fire, time, and human craftsmanship. In this video, we'll journey deep into that process, from unremarkable clay to a finished brick, from humble raw material to the backbone of trillion-dollar structures across the United States and around the world. Bricks are among the oldest building materials ever created, first appearing more than 9,000 years ago in Mesopotamia, the cradle of many ancient civilizations. From sun-dried clay blocks, humans invented the firing technique to increase strength, ushering in a new era of durable architecture. From the walls of Babylon to the structures of Rome, bricks have shaped the face of cities and remained central to construction for millennia. In the face of escalating plastic pollution, many countries have transformed plastic waste into strong, lightweight building bricks. Plastic is collected, sorted, cleaned, and ground into small particles, then mixed with sand or stone powder before being pressed under high heat and pressure. The result is not only exceptionally strong, waterproof, and well-insulated, but also up to 40% lighter than clay bricks. By repurposing a material that is notoriously slow to decompose, these bricks both reduce environmental pressure and open new pathways for sustainable construction. From the legacy of ancient structures to the green innovations of the 21st century, bricks continue to prove their remarkable endurance and adaptability. The journey of a brick begins at clay quarries, deposits that have accumulated minerals over tens of thousands of years, often lying 1 to 2 meters beneath the surface. Before any machinery breaks ground, geological engineers drill test cores, collect samples, and analyze particle size, mineral ratios, moisture content, and iron oxide levels, the latter being a key factor in determining the brick's final color after firing. Once the extraction site is confirmed, large bucket excavators or specialized scrapers remove the topsoil and dig down to reach the pure clay layer. These clay masses are carefully separated to avoid contamination from debris, roots, or hard stones, which could damage crushing equipment in later stages. Each bucket load is tipped into high-capacity dump trucks, with every trip carrying dozens of tons to a pre-processing station at the quarry or directly to the manufacturing plant. In modern facilities, enclosed conveyor systems and sealed hoppers are used to minimize material loss and reduce dust emissions into the surrounding environment. This is not merely the first step of production. It is the stage that determines the purity, strength, and quality of every brick that will eventually come out of the kiln. After leaving the quarry, the raw clay is fed into a jaw crusher or heavy-duty roller crusher, where rotating steel shafts press and shear each block down to a few centimeters in size while removing stones and hard impurities. The material then passes through a fine crusher, either hammer type or multi-roll, to reduce particle size to a uniform level, improving cohesion and workability for shaping. A vibrating screen retains the particles that meet specifications, while oversized pieces are returned for further crushing to avoid wasting material. Once the particle size is stabilized, the clay moves to the mixing system. Batches from different sources are precisely weighed and blended in a screw mixer or rotary drum, ensuring moisture content and mineral composition are evenly distributed. In some plants, the clay is also aged in sealed pits for several hours, so the moisture penetrates deeply into each particle, increasing plasticity and reducing the risk of cracking during forming. The result is a homogeneous, fine, and stable feedstock, ready to enter the shaping stage with optimal quality. At the plant, the clay is fed into a mixing system, where high-power rotating paddles continuously turn, press, and break down each raw lump. During this process, water is added in precisely calculated amounts to make the clay soft, pliable, and uniform. Moisture control is critical. If the clay is too dry, it will crumble during forming. If too wet, it will turn into a loose slurry that cannot hold its shape. Some mixers are equipped with internal scrapers that prevent material from sticking to the walls, ensuring the entire batch is processed evenly. To ease the demand on natural clay reserves, many modern plants incorporate recycled materials such as fly ash, treatment sludge, or excavated soil from construction sites. This approach not only conserves extracted resources, but also helps manage significant volumes of industrial solid waste. Regardless of the additives used, the end goal remains the same: achieving a perfectly consistent mixture. Moisture sensors monitor the blend in real time, but in many facilities, workers still perform a final manual check, lightly pressing a handful of clay to feel its fineness, cohesion, and how well it holds its form. Once the material meets specifications, it moves on to the next stage of production. Once the clay has been evenly mixed and reaches its ideal plasticity, it is transferred to the shaping area, where the first form of each brick takes shape. Here, the clay mass is fed into a continuous extrusion system, where a screw or piston drives the material forward under high pressure. This force compacts the clay from a soft mass into a long, straight, uniform column, essentially an uncut brick bar. The column passes through a precision-engineered steel die, manufactured to exact tolerances. Its surfaces are polished and lubricated to reduce friction, ensuring the finished bricks have sharp edges, true corners, and consistent dimensions. For bricks, the extruded clay column moves directly to a wire or blade cutter, which slices it into individual units with precise length and perfectly square ends. Roof tiles, however, follow a different process. The clay is pressed directly into single curved molds, then moved to a trimming station. There, specialized blades remove excess material, round edges, or form ridge lines, depending on the design. Precision here is critical, as even minor deviations can prevent the tiles from fitting correctly when laid on a roof. After cutting, tiles are placed on flat trays or dedicated racks in their proper orientation to maintain shape and prevent warping during drying and before firing. After shaping, the bricks are moved to the drying area, typically a large, well-ventilated shed with a roof to shield them from direct sun and rain. At first, the bricks are laid flat to maximize surface contact with the air, then set upright so moisture can escape evenly from all sides, reducing the risk of warping or cracking. Though this step may seem simple, it requires constant attention. Uneven moisture or improper placement can cause an entire batch to lose its proper form, compromising both strength and appearance. Once completely dry, the bricks are loaded into the kiln, where temperatures exceeding 1,000 Kelvin complete their transformation from clay to a durable building material. Workers stack the bricks in tight layers while leaving narrow gaps to allow heat and flame to reach every corner. In some traditional kilns, ceramic spacer bars are placed between the brick layers to maintain precise gaps and ensure a stable flow of hot air. This careful arrangement ensures even firing and minimizes cracking caused by uneven heat distribution. The firing process can last many hours, sometimes an entire day and night, and demands constant monitoring. Skilled kiln operators watch the color of the flames, listen to the faint crackling sounds of the material, and sense changes in airflow and odors to make timely adjustments. Only when the temperature is kept steady throughout will each brick achieve the desired hardness, color, and long-term durability. Once the kiln has cooled completely, the doors are opened to reveal bricks that have truly come of age, ready to serve as the foundation for decades of use. Only bricks that pass the final inspection for dimensions, color, flatness, and compressive strength are moved to the storage area. Here they are stacked neatly in tall piles with alternating perpendicular layers to maintain stability and allow air circulation. Each stack resembles a heavy solid block, perfectly aligned and awaiting transport. In modern plants, bricks are bundled into batches with steel straps or wrapped in moisture-resistant nylon, then lifted by forklifts onto trucks or into containers. In some facilities, bricks are transferred directly from the production line to transport vehicles, minimizing storage time. From the moment they were just layers of clay mixed with grass in the field, to the moment they become neatly packed bricks on a pallet, the journey comes full circle. Quiet, enduring, and precise to the smallest detail, much like the way each brick will rest in a wall for many years to come. Not every lump of clay ends its journey within the walls of a building. From the same clay source, some portions are shaped thinner and more curved, not made to bear weight from the ground up, but to shield from the roof down. These become roof tiles, another branch of fired clay carrying an equally important role, protecting the structure from sun and rain while completing the lines and appearance of the roof. Although also made from clay, the distinctive shape of tiles requires a completely different forming process. Instead of being extruded and cut like bricks, the clay is pressed directly into curved molds with a concave surface, a raised ridge along the back, and edge flanges designed to grip the roof and channel away water. The press applies just the right amount of pressure, after which each tile is gently released and placed individually on flat trays to prevent warping during drying. In some plants, tiles are pressed a second time to smooth the edges and reinforce the ridge, improving durability once installed. Each tile takes only seconds to produce, but achieving that perfect shape requires every detail of the mold and pressing parameters to be carefully calculated and fine-tuned to near perfection. After being pressed into the curved mold, each roof tile moves to the trimming station, where specialized blades remove excess clay, round the edges, and form the ridge exactly as designed. Every operation must be precise, as even a slight deviation can compromise the tile's fit when laid on a roof. For glazed roof tiles, while they still retain some moisture after shaping, each piece is sent to the glazing stage, a coating made from refined clay, minerals, and metal oxides. The glaze is either sprayed or dipped directly onto the surface, forming a thin, even layer that will give the tile its final color, water resistance, and weather durability after firing. Immediately afterward, the tiles move into a drying chamber, where temperature and humidity are carefully controlled. Streams of hot, dry air gradually draw moisture from both the clay body and the glaze, preventing cracking or warping. Though this step lasts only a few hours, it is critical for ensuring stability and visual quality before the tiles enter the kiln. Once properly glazed and dried, the tiles are transferred to the kiln, where temperatures often exceed 1,000 degree Celsius, hot enough to vitrify the clay body and melt the glaze into a smooth, firmly bonded surface. Compared to bricks, firing tiles demand stricter stacking and spacing techniques. Each piece is placed on racks or set atop refractory spacers to ensure glazed surfaces never touch, preventing sticking or scratching. Modern kilns use controlled burners and heat circulation fans to maintain even temperature throughout the firing chamber, while traditional kilns require skilled operators to constantly adjust fuel supply and airflow to keep the heat and flame stable. Once removed from the kiln, each roof tile undergoes a rigorous inspection to ensure it meets both technical and aesthetic standards. Workers carefully examine the surface for glaze defects, such as peeling, discoloration, or pinholes, while also checking shape, curvature, and dimensional consistency. Specialized gauges are used to measure warpage and thickness, comparing the results to design specifications. Only tiles that meet all criteria proceed to the packaging area, while defective pieces are discarded, sometimes crushed for recycling. A durable roof always begins with tiles free from even the slightest flaw. Stepping onto the construction site, bricks, whether the square blocks within the walls or the curved tiles on the roof, have all traveled a long journey to reach their rightful place. Beneath, they bear the weight of the entire structure. Above, they withstand rain, sun, wind, dust, and the passage of time. Few notice it, but every brick laid is a promise that this place will stand firm, that this roof will provide shelter. And so, from foundation to rooftop, they silently follow one another, binding together not just materials, but the very sense of security people feel within their own home. From raw brown clay to perfectly shaped bricks bearing the weight of entire walls, each one is the result of skill, control, and labor, measured down to the finest detail. A process that may seem simple, yet behind it lies an unbroken chain of technology, where every trace of moisture in the clay and every second in the kiln can determine the lifespan of a structure for centuries. Thank you for joining us on this journey to explore a material that feels familiar, yet is rarely seen in its entirety. Bricks and roof tiles don't just build walls and roofs. They tell the story of how humans combine knowledge, skill, and labor to transform clay into the foundation of lasting structures. If this video has made you appreciate the silent bricks beneath your feet and the steadfast tiles above your head, please like and subscribe. Because behind every familiar material lies a fascinating journey where technology, people, and nature intersect in ways you may have never imagined.